In this question, we have to figure out the vector equation, parametric equation, and Cartesian equation of a line, which is passing through a given point and in the direction 4i plus 5j minus 6k. Now, since we already know the vector equation of a line is given by a plus lambda b, where a stands for the position vector of the point which is already lying on the line, which in this case is 1, minus 2, and 3. So let's write a vector in the column vector notation. So a vector will be 1, minus 2, and 3 plus lambda times b vector is called the direction vector, which is a vector parallel to the given line, which is 4, 5, and minus 6. And for r on the left hand side, we will write x, y, and z. So this is the vector equation of the line. Now let's convert the same into parametric equation. So all we need to do is we have x on the left hand side. On the right hand side, we'll have 1 plus 4 lambda. So let's write x is equal to 1 plus 4 lambda. Similarly, y on the left hand side and on the RHS, we'll have minus 2 plus 5 lambda. And similarly, for the z component, we'll have 3 minus 6 lambda. Now, since all these equations are in terms of a parameter lambda, that's why these are called the parametric equations. And how do we convert this into the Cartesian equation? All we need to do is make lambda as the subject from every equation and then equate. So let's see. If we make lambda as the subject from the first equation, we'll get x minus 1 upon 4 equals to lambda from the second equation will become y plus 2 upon 5, and similarly z minus 3 upon minus 6. So this is the Cartesian equation. We have been given two lines and the vector equations are given. The two lines intersect at point M. We need to find the coordinates of M. Now observe, these are vector equations first of all, and we need to find the coordinates of the point where they intersect. So all we need to do is just equate the x, y, and z components. So r, remember, is x, y, z. So let's write it down. R will be x, y, z for both cases. And since the intersection point is the same, so that is why we will equate the x component which comes from the first equation with the x component which comes from the second line. So which means 3p plus 4 will be equal to q minus 2. Let's write that down. Equals to q minus 2. Similarly, equate the y components. 2p minus 1 will be equal to 1 minus q. And similarly, let's equate the z components. P plus 9 will be equal to 2q plus 1. As we can see that these are three equations and we have two variables. So just use the calculator. These are simultaneous equations. Get the values of p and q. We will get p as negative 0.8 and the value of q as 3.6. Now in part A, we were supposed to find the coordinates. So what we need to do, either use p or q and put that in any of these equations. If we are using p, which is negative 0.8, put that in the equation for the first line. So in that case, the coordinate will be 3p plus 4, 2p minus 1, and p plus 9. After you put p is equal to minus 0.8, the coordinates which we get of point M will be 1.6, comma, minus 2.6, comma, 8.2. Now we will get the same answer if we put q is equal to 3.6, but that needs to be put in the second equation. Moving to part B, find the acute angle between the two lines. Let's revise the concept. How do we find angle between the two lines? We use the dot product principle. Angle between the lines is equal to angle between their direction vectors. So we need to identify what are the B1 and B2 vectors from these two equations. Let's start with line L1, whose vector equation is given. So let's write it. R will is written as 3 plus 4, 2p minus 1, and p plus 9. Now remember, the basic general vector equation of a line looks like r is equal to a plus lambda b. So we have to somehow transform this given equation into this form. So let's do that. So we'll take P common. So we'll get 3, 2, 1. And then with a plus, we'll write 4, -1, and 9. Now we can compare this with the standard equation of the line. Lambda, the parameter in this case is P. So the equation is lambda times B. Lambda is P. B is this vector and A vector is this. So for the line 1, B1 vector comes out as 3, 2, and 1. Let's use the exact same logic for the second line, L2. So L2 is x component is q minus 2, 1 minus q is the y component, and 2q plus 1 is the z component. So let's split this. So let's take q as common. We'll get a 1, -1, and 2. Notice in the x component, we have 1 into q. In the y component, we have a negative q. That's why we have placed a -1 sign here. And for the z component, you have a 2 in front of a q. So that's why this. And all the other numbers will form the A vector, -2, 1, and 1. That's why for the second line, the B2 vector comes out as 1, -1, and 2. Let's now find out the acute angle between the two lines. So the formula goes like cos theta is B1 dot B2 divided by the two magnitudes. B1 dot B2. So B1 is 3, 2, 1, and B2 is 1, -1, 2. To find the dot product, we just multiply the x components together, the y components together, the z components together, and then we add it. 3 into 1 plus 2 into -1 plus 1 into 2. Let's simplify this. 3 minus 2 plus 2, which comes out as 3. So that's the numerator of this particular expression. So cos theta is equal to 3 divided by, now B1 is 3, 2, and 1. So the magnitude will be 3 square plus 2 square plus 1 square. B2, on the other hand, is 1, -1, and 2. So we'll get square root of 1 square plus -1 square plus 2 square. Let's simplify this entire expression. Cos theta comes out as 3 divided by square root of, this is 9 plus 4, 13 plus 1, 14, multiplied by root of this on the right hand side, 1 plus 1, 2, 2 plus 4 is 6. And if we simplify this expression by taking cos inverse, so the value of theta which we are going to get is 1.24 radians, or if we are solving degrees, we'll get 70.9 degrees. And that's how we find the angle between these two lines. The shortest distance from a point to a line. Have a look at this picture. We have a line, a red line, whose vector equation is a plus lambda b. Let's revise. A is the position vector of the point, which is already lying on the line. B vector is a vector which is parallel to the given line. The concept which we have to study here is how do we find the shortest distance from a point to a line. So randomly, let's say we have been given a point P. How do we find the shortest distance? We draw a perpendicular starting from the point P all the way till Q. So the PQ line segment will be perpendicular to the line. So which means this angle is 90 degree. Now, whenever in vectors you see the angle 90 degrees, always take the help of dot product. Because remember the formula for dot product, A dot B is magnitude of A, magnitude of B into cos theta. But whenever the angle theta is 90, cos 90 is equal to 0. Hence, remember, whenever any two vectors are perpendicular, their dot product is always 0. So in this particular case, we will consider PQ as one vector which is perpendicular to the line. Now B is the vector which is parallel to the given line. Hence, we can write that PQ is also perpendicular to the parallel vector. Now, since the vectors are perpendicular, we need to take the dot product of both of them and put that equal to 0. And how do we find PQ vector? That will be Q minus p. Now, p vector will be given in the question. That's the point. A q vector is any random point lying on the line, but it is the shortest distance from point P. So, how do we find q? Q is found from the vector equation. So, we'll understand this in much more detail in the next example.